We introduce a method to efficiently reduce aliasing artifacts when rendering triangle meshes. A major component of the aliasing occurs along discontinuity edges, such as silhouettes, creases, and material boundaries. 2x2 supersampling reduces aliasing somewhat, but artifacts are still easy to see. In addition, it can significantly increase rendering time and consumes memory that could be devoted to storing texture maps or geometry. Our method addresses aliasing artifacts by overdrawing discontinuity edges as anti-aliased lines, a feature commonly available in hardware. We use an efficient silhouette extraction algorithm in order to make the approach practical for large models. Our approach is to first render the model, followed by the anti-aliased lines. The method is particularly effective at reducing temporal aliasing. In this side-by-side comparison, note the absence of crawling jaggies using edge overdraw on the right. In order to achieve good results, several subtleties arise. This video highlights two of our contributions, edge blending and edge sorting. Due to the limitations of VHS, the other two are most evident in the paper figures. Unless sharp edges are blended, they can approach the silhouette with the wrong shading, resulting in popping. In this example, look at the top of the cube. Note the popping artifact on the left window as the sharp blue edge suddenly changes color. On the right window, the edge is properly blended as described in the paper. The anti-aliased lines are drawn using the over operation. Because this operation is non-commutative, the results are strictly correct only if the edges are drawn from back to front. We can occasionally get artifacts when silhouettes lie in front of other discontinuity paths, as shown on the left window. We can solve this by sorting the edges that are on or near the silhouette from back to front prior to rendering them, as shown on the right. For many smooth organic models, sorting provides little, if any, improvement. Now we will show examples of discontinuity edge overdraw in a few meshes. In some high-resolution models with a large proportion of discontinuity edges, rendering time can be affected significantly by our approach. The edge overdrawn model on the right takes about twice the time to render compared to the aliased model on the left. For models with few sharp edges, the overhead of edge overdraw is small due to our fast silhouette extraction algorithm. As shown here, our method also works well on texture map discontinuities due to the availability of texture map lines as rendering primitives. Here's an example of our approach applied to a small model. The time overhead is very small. Here is another example. Once again, the aliased rendering is shown on the left, while the edge overdrawn one is on the right. This video was shot using a Pentium 3 800 MHz machine with an NVIDIA GeForce 2 graphics card.